This transmission network model example demonstrates the use of transfer capacity analysis, one of the transmission network tools. For this example, study case transmission network tools TCA, and scenario-based scenario should be activated. Transfer capacity analysis is used to determine the maximum feasible power flow between two parts of a network by scaling demand or generation in opposite directions in the two parts. Load flow calculations are executed at each step until the critical point is reached. Let us first run a load flow to see the initial state of the network. In this example, we will consider the transfer between the southeast and the rest of the network. The NESE interconnector forms the boundary between these two parts of the network. Looking at the overview diagram, we can see that the initial flow across this boundary is about 73 megawatts. On the Transmission Network Tools toolbar, this button can be used to set up the transfer capacity analysis. Two regions are selected, one is the exporting region and one is the importing region. These can be defined by grids, zones, areas or boundaries. We will select as our exporting region the boundary NESE interconnector. The importing region will be the rest of the network. To define a boundary for this, we can simply copy the NESE boundary in a network model manager and reverse it. Returning to the transfer capacity analysis dialog, this new boundary is selected as the importing region. Notice how the two interconnecting lines are automatically identified. The analysis can be carried out by scaling generation or demand or both. In this case we will scale the generation. We will look now at the constraints page, where the constraining limits are defined. The option to consider thermal constraints is selected, meaning that the thermal ratings of branches will act as limiting factors. In addition, the active power limits of generators will be observed. There are also options to save the output of the analysis, but in this example we will not do this. The analysis is executed and we can see in the output window that the total transfer from the southeast to the rest of the network has a limit of about 940 megawatts. No thermal ratings have been exceeded. The transfer limit has been found when no more generation can be scaled down in the rest of the network. In reality, the transfer across a boundary may be limited by the impact of potential faults on the network. Returning again to the transfer capacity analysis dialog, we can see that there is an option to consider contingencies. If this is selected, the contingency analysis dialog box is made available. In this case all the line faults have already been selected. Before executing the analysis, there is a further consideration. It is likely that elements overloaded due to faults will be able to exceed their thermal rating for a limited time, provided that post-fault actions to reduce the overload are available. For this reason, we will increase the maximum thermal rating to 150%. The analysis is now executed. Looking at the output window, we can see that the maximum transfer is now about 760 megawatts. The limiting contingency is also indicated.